Okay, welcome to video 1.12. This video begins on page 17 of your workbook and it will end on page 24, and the concepts that we are going to be discussing are working with what's known as partial variation and working with negative slope. Now again, this is all about linear relations, it's all about lines, and it's all about being able to graph lines on a graph on an x and a y axis. Okay, before we begin doing any examples, we need to understand what a partial linear relation is. Well, in the previous video we talked about what a direct linear relation was, and that was a relation where a line passes through the origin, through the coordinate 0, 0. And what happens if we don't have a line that passes through the coordinate 0, 0? In other words, it passes anywhere but. That type of linear relation is what we call a partial linear relation. So if I can just draw this here, we have a graph showing the x and the y axis, and there's our origin, 0 and 0. If I have a line that passes through the origin, straight line, this line is called a direct linear relation. Well, supposing I have a line that passes anywhere but there, maybe I have a line that goes like this. Maybe I have a line that goes like this. It doesn't pass through the origin. That is what we call a partial linear relation. Okay? Another concept we want to talk about is also the definitions of intercepts. Now we know this is our y-axis, we know that this is our x-axis, so we have lines passing through, we can have lines passing through these axes. So let's say I've got a line that goes like this. So I could basically continue the graph looking like this. It goes that way, and it goes that way. And it continue on, let's say, for infinity that way, and it goes for infinity that way. You'll see that it crosses the y-axis right there. This point where it crosses the y-axis, just put a little arrow there, this is called the y-intercept. And let's say I have a line that goes like that, and it passes through this axis right here, the x-axis. This point right here where it crosses the x-axis is known as the x-intercept. Now obviously this line could continue forever that way, and so this line would have both an x and a y-intercept, and this line would continue that way, and there would be the x-intercept for that one. So up until now we've been talking about lines that have slopes that are positive. So what do I mean by a positive slope? Well, if we have a line on an axis, and the line goes in a direction of up and to the right, that's known as a positive slope. But what happens if we have a line that goes the opposite direction? Perhaps it goes like this, down and to the right. Well, a line that has a slope that goes down and to the right is what we call a negative slope. We also have two other situations that we could have. What happens if I have a line that is, let's say, runs perfectly horizontal with the x-axis? Well, we just call that a horizontal line. Has a horizontal slope. Okay. And we could have another situation where we have a line that is perfectly vertical. Okay. This is a vertical line. So we have four situations here. We can have a positive slope, we can have a negative slope, we can have a horizontal line, Basically, it's horizontal slope. It's a zero slope, okay, because it has no slope at all, and we have a vertical line. All right, well, let's work through an example that might illustrate this concept of partial linear variation. Okay, so let's look at example 3 in the workbook on page 17, and we can see we have an example of an electrician who is working for a living, and he charges $45 just to show up to your house, and he charges $35 for each hour of work. All right, so it asks us to create a table of values showing his earnings after each hour up to 5 hours. Draw a graph of that. Ask if it's, or answer the question, is it partial or direct linear relation? What is the slope of the graph? And what are the x and the y intercepts? Well, what we want to do right away is we want to create a table of the data that we have, and we want to be able to write it down. So creating a table of data just means that we can make a box. So if you're asked to do any example where you have to create a table, this is basically how you do it. You'd want to put a title in here. Okay, then you're going to want to divide it up into 2 columns. Okay, and then under here you have to label, you have to have a label for your column. So we're going to call this the we'll call this hours, because we know that from the information we're given how much he charges per hour, and this would be his earnings in dollars. So it asks us in part A to create a table going up to 5 hours. Well, it just says that he, just to even show up at the job, he charges $45 an hour. He hasn't done any work. He charges $45 an hour just for a house call. Okay, so we have to put that information in. So he charges $45 and he has worked 0 hours. And then he charges $35 per hour after each one of those. So we're going to go up to 5 hours. So there's 1, 2, 3, 4, and 5. And $35 an hour. I add 35 to 45 and I get 80. And then 115, add 35 more dollars to 80, get $115. And then $150, then $185, and then $220. Okay, so he shows up to the house, he hasn't worked any hours, and he's going to charge just for a visit, just to look at the problem, $45. Now it says to graph this, so we have a table of values, and we have to decide, look at the data, and we have to decide, well, when I graph this, what data goes on which axis? This is my y-axis, this is my x-axis. So from our previous lesson on 1.11, we talked about independent data and dependent data. So we have to ask ourselves the question, what piece of information depends on what? Do his earnings depend on the number of hours that he works, or do his hours depend on the earnings? Well, we know that the earnings depend on the hours. So if the earnings depend, that means that the earnings go on the y-axis. So this will be the dollars, that's his earnings, and this here will be H for hours. So we know that this is 0. It's 0 hours, $0. And we just go up to 5 hours, 1, 2, 3, 4, and 5. And we can put his earnings up here. Now, scale is very important. When you're drawing a graph, you want to make sure that you get an appropriate scale. You don't want to, we know that the highest value of earnings is $220, so we would not want to put 220 way down here. That means our line would be way too small and our graph would be really compressed. We want to make sure that we utilize as much of the axes as possible. That way we get a better looking graph. So we'll go up in maybe increments of 50. So there's $50, there's 100, there's 150, and we'll say that's 200. Now we know we're going up to 220, so it's going to be somewhere up here. Okay, so we're going to utilize the entire graph. And now we just take the information we have over here and we just plot it as coordinates. So our first coordinate is 0 hours, $45. So I go to 0 hours and I'm going to mark 45 here on my graph. And then after 1 hour he's at 80, so I go to 1 hour and I go up to about $80, and I have to kind of make an educated guess as to where that point's going to be. 2 and 1, 15. The one thing I do know is that because all of these pieces of data are going up at a constant rate, okay, from here to here is $35 and 35 and 35, etc. And from here to here is 1 hour and 1 hour and 1 hour and 1 hour. Because both pieces of data are going up consistently at a constant rate, I know that I have to have a straight line. Okay, so whenever you're plotting your data and from your table you can see that there's a consistency between your x values and your y values, between your data points, then you know that you're going to get a straight line. Okay, so at 3 hours he's worked 150, or made $150. 4, 185, and then 5, 220, something like that. So we connect the dots like that, and we know that our information passes through the y-axis. In other words, has a y-intercept of 45. Okay, so we have drawn the graph. Now what we want to do is we want to ask ourselves the question, is this a linear relation? Well, I just explained that it is a linear relation because the data difference between the data points are the same on both sides, so that we have a constant on both. So that means that it is a linear relation, a straight line. Is it partial? Is it direct? Well, the definition of a direct linear relation is it passes through the origin. This does not pass through the origin. It passes through point 45 on the y-axis. So this is what we call a partial linear relation. Now we want to calculate the slope. Well, to calculate the slope, we just go to the slope formula, which we learned from last video. Slope is just equal to, if I take any 2 points, doesn't matter which ones I take, y2 minus y1 divided by x2 minus x1. I just substitute, there's my formula, I substitute into the formula. I will choose, let's say, the last point, 5 hours and $220, and maybe I'll take 2 hours and 115. Okay, so I will take my y2, 220, subtract 115, divided by 5 hours subtract 2 hours, is equal to 220 subtract 15 is 105. 5 subtract 2 is 3, and 105 divided by 3 is 35. And you'll notice that the 35 here is our slope, and notice how it also corresponds to how much money he was making per hour, because this is a 1 over here. So if I take 35 divided by 1, because it's constant, it shows my slope. So my slope is just 35. Alright, let's just extend the page just a wee bit. And the last part, D, it says, what is the y-intercept and what does it represent? Well, the y-intercept, as I explained, is where it crosses the y-axis, and the y-intercept we know is 45. And what does that represent? Well, that represents the initial startup cost in this case, because we're talking about earnings and hours. Initial startup cost, or the initial amount of money that a client or a customer would have had to pay Loris, the electrician, just to show up to the house. Okay, so where it crosses the y-axis, that is the initial starting point. Okay, and then we have to explain what that means. Okay, so that is what the y-intercept represents. Okay, so that ends the this video. So work in your workbooks up to page 24. There's a couple of good graphing problems that you can work on, one including using negative slope. Okay.